This is the lesson for Chapter 10, Section 3, titled Quotient of Powers Property, day number 1. So before we get to the key idea, I'm going to go over how the key idea ends up working. So we've got, let's say, 4 to the 5th power, like they said here, over 4 to the 2nd. And so what we're going to end up seeing is if we go ahead and expand this out as 5 4s being multiplied together, and then in the denominator I do the same sort of thing, but instead of 5 we just have 2 because that's what the exponent tells us. What happens is these two 4s are going to cancel out, and when we cancel them out they make a 1. And we'll do the same thing with this one as well. When we cancel them out they make 1. And so what we're left with are 4 or 3 4s being multiplied together, so that would be 4 to the 3rd power. And these two 1s, well, when we multiply one by a number, it doesn't change the value. And so what we'll end up seeing is we're taking away the denominator's exponents, or the number of values that we have that are the same in the denominator as we have on top. And that's what we see here in the rule. It says to divide powers with the same base. Again, they have to have the same base. We can subtract the exponents because basically we're taking away the number of 4s we have in the denominator from the number of 4s that we have in the numerator. And that's how we're left with this value. So again, the value of 4, as long as the base is the same, we're going to be able to use this rule. And so we'll see that with these problems here. It doesn't matter whether it's a negative number or positive number. Now I know this is 4 negative 3's being multiplied because it's in parentheses. So my rule would be this. I could go ahead and subtract the exponents. 4 minus 1, so I should end up with negative 3 to the 3rd power. Now it needs to be in parentheses because it's negative 3 to that 3rd power, not the opposite of 3 to the 3rd power, even though both would give the same answer. So from there, let's go ahead and take a look at what it would look like if we had multiplied out those values. So we've got 4 negative 3's being multiplied. Down below we just have 1 negative 3, and you can see how one of those negative 3's on the bottom will cancel out 1 on the top, leaving us with the number 1. And so that leaves us with these 3 negative 3's, and that's how we're getting this answer. So looking at this one, we have 5 to the 9th over 5 to the 3rd. Again, we're using the rule, so we go ahead and subtract the exponents. And that leaves me with 5 to the 6th power. And so that would be our answer. Again, if we saw that written out, it would be 9, or actually this would be 5's instead of 9. So if we wrote out 5 9 times, though, there's 5, 6, 7, 8, 9. And then down below we have 3 5's being multiplied. You can see how these 3 5's down below will cancel out 3 5's up top, and that's how I'm left with those 6 5's. That's why it's 5 to the 6th power. Now, here's the common error people are going to make. So this is the common error. And so especially with a problem like this, they won't usually make it with this type of problem here, but definitely with this one they might. And so since 3 goes into 9, since we're dividing, whenever the exponent goes into the exponent on top, sometimes people will do this. They will divide the exponents, and they won't use the rule, and that would be wrong. And so again, this is the part that's wrong here. We've got to subtract the exponents, not divide the exponents. And so that's a key common error, and especially in a problem like this, if you had, let's say, maybe like 4 to the 16th power over 4 to the 4th power. So this would end up being 4 to the 12th because I have to subtract the exponents, and I get 4 to the 12th power. That would be the correct answer. The common error, again, would be to divide the exponents, and that would be wrong. So watch for that. So let's take a look at the next problem. So the next set of problems will have more than one operation going on. So what I would recommend doing is go ahead and combine what's in the numerator and the denominator before you do any quotient of powers properties. So I'm going to keep the c to the 22nd on top. Down below I'm going to add the exponents. That's the rule we're going to use. And we're left with c to the 22nd on top still. We have c to the 17th on the bottom. So now I'm going to use that quotient of powers rule. So in this case, all we're going to do is subtract the 17 from 22, and that leaves us with c to the 5th power as our answer. So same sort of thing on this one. The difference is that you don't see the fraction bar going all the way across, but it's the same thing. I would just go ahead and multiply the numbers on top. So k to the 13th plus 17th. So I'm adding up the exponents on top. Do the same thing in the denominator, 5 plus 11. and that leaves me with k to the 30th power on top, and down below I have k to the 16th power. So now I'll go ahead and use that quotient of powers property and subtract the exponents. So I do 16 from 30, that leaves me with k to the 14th power. Again, there's other ways to do it. We could have subtracted initially, and I could have gotten k to the 8th power, so I could have taken this expression right here and done k to the 13th minus 5, and then multiplied it by k to the 17th minus 11. And so when we subtract the 5 from 13, that leaves me with k to the 8th, and then times by, and then subtracting these two terms, leaves me with k to the 6th, and then I would end up having to add, and I have 8 plus 6 leaves me with k to the 14th power. So lots of ways to come up with that same answer. Any way you feel is best, go for it. Those are the types of problems you're going to see on tonight's assignment. Good luck.